Welcome back to Bexhill West and the chaos of my workbench. Thank you for joining me. Now, today's episode should be the continuation of the build of this brake van that I started last time. However, I've reached a little bit of a snag. The next stage was to assemble the sprung suspension units that need to go under that. I've got another one here, I'll show you. This is one I made previously, and there's the sprung suspension. And I got as far as making up two of those units. In fact, I might put a little bit of footage of that just behind me for you to have a look at. And then they disappeared. I can't find them anywhere. I've put them down and somewhere amongst you, I don't know where, they've disappeared. And that's really held the job up. So I ordered some replacements, but unfortunately they're not available currently. So I sort of held on and held on. I found another supplier and they're on their way now, but that build has been sort of rather held up because I wanted to put those on before anything was painted. So rather than wait any longer, and that's the reason why there's been such a delay between my last video and this one, I thought rather than sort of wait for those bits to arrive and then continue with that build, today will be a little bit of a one-off special episode, and I'll run through some of the things I've been making behind the scenes, and I'll try and explain briefly what they are, what their relevance to my project is, etc, etc. And hopefully there'll be a mixed bag of ideas and things that might be interesting to have a look at. So without further ado, I shall get straight onto it. The brake van isn't forgotten, we'll come back to that early next year. Thanks for watching. Okay, so to begin with, I'll show you this. Now, you've seen I've spoken ad nauseum in the past about mechanical interlocking, and it's something that I've really been enjoying learning something about. Now, chatting with a couple of friends over the summer, and I said that of the 123 levers in the number one box at Bexhill, I was going to reduce that down. By the end of its life, many of those levers weren't in use, so it seemed to me make sense, let's knock it down. And I think I'd worked out I could get it down to about 59 levers and still have everything signalled correctly. But Luke, my friend the signalman who I've mentioned on the channel before, he said that really I ought to keep the numbers the same, and even if I reduced the numbers of levers in the frame, I ought to keep the numbers the same so that the levers would operate in accordance with the interlocking sort of table for the box. Well, that got me thinking, and really that's a compromise. You know, it might, for example, go lever 1, lever 9, lever 18, 25, and it would just look odd. So I thought, can I refine things and actually build the full 123 levers? Luke also pointed out that I could put the interlocking for the whole 123 levers in and do the interlocking just as it would have been when it was sort of built, but only use that on the levers that were in use. I thought that's quite a fun sort of intellectual challenge, so I thought, well, let's go about doing that. But for that, there's a couple of snags. Firstly, it was my intention to use the Scale 4 Society lever frames. Now, these are brilliant, they're really well designed, they're great fun to make, and they just work beautifully. It's a really nice piece of design. But the thought of building 123 levers worth of this and the associated interlocking, because they do an interlocking kit that sort of goes onto here, that sort of terrified me a little bit. Not least the fact it would take me forever to do, but also proved to be quite expensive. So I thought, well, could I come up with a simple way of doing 123 levers that worked as accurately as possible, that would be quick to put together and, you know, a little bit more cost effective. So I revisited the design of my interlocking kit that I'd come up with and shown previously on the channel. I came up with this one. Now, I did this back in September to take to the Scale Forum, and this is designed basically around the Westinghouse principle, which was derived from the Evans O'Donnell frame, which was at Bexhill West. So I'll bring you in closer and I'll explain it all in a little bit more detail. So here's a closer view. It's very similar to what I had previously, except that the dogs are replaceable. So over time at Bexhill West there were changes to the track work and the signalling, and I can effect those changes on here. Plus, if I make a mistake, which is very likely, it will be no problem to change these things out. I'm still learning about all of this, so it's a case of I'm building in the facility for me to sort of trial and error it a little bit. Now I've made a big box of all the different types of dog or locks that I can think of, and I've started drawing up the table. What I need to do, I think, is get onto the Signal Record Society and see if I can get hold of the original locking table for Bexhill West. But anyway, that was the locking frame. Now when I made my first kit, of which this is a development, I thought I'll make it nice and big so it's not fiddly and I can sort of work on it. But it occurred to me it's quite nice being big. So this, alongside of the model, is going to be sort of proudly displayed and intentionally nice and big so that people could see it work and see how it operates. And it'd be my ambition that somebody would look at the model one day and ask a question about the signalling and they'd be able to see all of this. Certainly when I first saw an example working, and I made a video of it, I shall link that up in the corner, but when I first saw that example working, the penny dropped. I sort of understood how it worked. So I think this would be fun for people who, like me, didn't really know too much about it, to be able to see what was going on. That said, what I needed was a means of driving it, and another reason for deciding to move away from the scale 4 frame is that the throw here is fixed. So for example, the notch in this tappet here has to travel from one locking row to the next one when the lever is thrown, and the scale 4 frame didn't provide the right amount of throw. Now I could mechanically put a linkage in and change it, but I thought, well, let's design a frame. So that's what I've done. So then, this is my mock-up, my first mock-up of the lever frame that will go in Bexhill West #1 box. Now I've only got 10 or so levers set up on here, but this is scalable. Now this is based on an Westinghouse A2 frame, and if we look at the end profile, it's closely copied from the original drawings. My plan is to have these laser cut in steel, and I think that would be suitably robust. One thing that has impressed me from sort of having a look at one of these frames for real is just how mechanical and heavy and clunky everything is when it works. So this will be built to be nice and chunky, so hopefully it has a similar feel. Now it's 1:10 scale, so this frame here is 1:10. These levers are exactly profiled or copied from the original drawings, and this arm, which would have come off to the wires that would have operated everything, this is again to scale. Now I'm not going to use these, but I have got an idea for a little idea where they might be useful, so I'm keeping those on. I've added a little linkage on the back just here, and this will connect to my interlocking tray. So as I say, it's 1:10 scale, but what I have done is I've stretched it out slightly this way. At a scale of 1:10, there would be 10mm between these levers, and really that's a bit close and a bit fiddly, so I've just spaced them out a little bit more so that they could be a little bit chunkier. Now I've not made the catches yet. That's straightforward. I've modelled them all up. They're going to work. So when I get these done in steel, then I will experiment with making those. Now if you have a look on the top here, each of these floor plates has been made individually, just like the real thing. But the real thing, these would be held on with 2 bolts on each side of each individual floor plate. Well, I've simplified that to just one. This is a model lever frame, it's not a model of a lever frame, so that's sort of a compromise that I'm happy to go with. You can see I snapped one of these levers off, dropping it. Anyway, that's the lever frame, and I'll show you how the locking tray will orientate itself with this. So what you're looking at here is my CAD model of the whole system, And one of the great things about modelling this in CAD first of all is that I can sort of check all the geometry and I know it's going to work. Now, one of the things with the Evans O'Donnell frame and the Westinghouse frame that sort of followed on from it is that the locking tray sits forward and at an angle, sort of diagonally slopes forward, corresponding with the little angle profile on the face of the frames. And that's really great. Having seen one of these in situ, it must be a signal engineer's delight to service because it's all easily accessible. Now, one of the other peculiarities with the Westinghouse frame was that the locking was activated by the catch handle. So you could actually grip the catch handle and tell whether that lever was locked rather than having to try and pull it. So I'm not sure if I'm going to replicate that feature. I think that might mechanically end up being a little bit too fussy and potentially fragile. But what you can see here is how the locking tray is going to sit on the front of that frame. So anybody operating the frame will be able to watch the locking working, and hopefully people looking at my model in years to come can take a bit of delight in watching that all work too. My real ambition would be for, if this thing went on display somewhere for, you know, members of the public or visitors, whatever, to actually use the thing. And I think this sort of extra bit of interactivity would be quite good fun, as well as hopefully being a little bit educational. So I'm not going to say too much more about this just yet. I just thought I'd give you a quick overview of the project as I've been working on it. So then what we have here is the CAD model for the lever frame showing how the interlocking tray will be connected. Now if I sort of wobble this around, try and manoeuvre it so that we're looking at it correctly, something like that. The Westinghouse frame, the locking tray is indeed located here. Now the locking tray in reality is relative in size to this one, it's much smaller. And it's what's called a catch handle locking frame, and one of the advantages of that is that the interlocking tray can be made much smaller. Now I'll get into what catch handle locking is when I look at this in a bit more depth, but I'm consciously keeping this overscale for the reasons I described previously. I think it's quite nice to watch working. Now I haven't set up all of the mates or the relationships between the different components yet in this CAD model, so if I operate the lever we can move or tap it, but it's not sliding that dog across as you might expect it to. And that's because I've been experimenting with this and chopping and changing it, so I need to put some of those mates back in and then it will all work. But geometrically it works. You can see there's a little linkage here which transfers the motion from that extra arm that I'd added onto the end of the lever, and that's what is affecting the movement. So that's all pretty good. I'm reasonably pleased with that. If we look around on this end of the frame, I'm going to incorporate some brackets for some micro switches so that the various servo driven turnouts and signals and things can all be controlled, and I anticipate building a bit of trunking or something along the back here where the wiring can go. Now I spoke about this lever here. This is scaled from the original drawing, and this would have had the cables coming off to operate the signals and the points. What I thought I might do is put springs on here and make the tension of those springs adjustable, so that the levers that work the signals and the points that are furthest away would have the heaviest spring, so that just like the real thing, there'd be a little bit of effort put into moving these levers, and the further away from the signal box the device is, the heavier it will be to pull. I think that would be quite nice, and given that this will all be robustly made out of steel, I think it'll be able to handle all the forces involved and hopefully make for a slightly better model. So the next item on today's agenda is this. Now this is a London, Chatham and Dover Railway cattle wagon, and this has been made for a friend of mine who wants a number of these to move some sheep. So this, what you can see here, is my first attempt at it. It's 3D printed. I've drawn it up on the computer. I'll put the drawing up on the screen. And for a first attempt, it's not too bad. I'm reasonably pleased with it. However, I've refined it a little bit more and come up with this one. And if we compare the two, hopefully the camera will show the detail. For example, on these strap hinges here, it's a little bit, although it's drawn to scale, it's not very well defined. And so on this one, I've just increased the dimensions of it a little bit, made it a bit thicker, a bit more prominent. So hopefully when that's painted, it will still show. Now we'll do a little close-up of that in just a minute, but it has led me to think of something where there's an opportunity to maybe show you a tip. So if we have a look, you can see on this side here, there's some wire, I don't know what you call those, guardrails or something, in those openings on the side, and that has required me to drill holes through the side of the 3D print. Now the bits themselves there are holes in there that the 3D printer has left, but they need opening up. Now if you just go at this with a drill, the chances are, because this material is quite brittle, that will shatter. So I'll show you how I went about drilling the holes on here. So what I've done is I've got a piece of the material, it's 0.3mm nickel silver wire. This is what I was going to use to make the rail, and although the camera can't see it, I've just cut the end off at 45 degrees with a pair of side cutters, and I'm going to use this as a drill bit, and this hopefully will allow me to get right through the side of the carriage, the wagon there. So we'll have a go and see how it does. And so here it is. That's the thing, the cattle wagon. It's turned out quite nicely. There's still some sort of 3D printer flash or whatever you call it that I've got to remove. This has literally just been sort of taken out of the printer, cleaned up and glued together quickly. It needs a lot more fettling. I wanted to see just how well it would work, and it's come out quite nicely. Now there are some sort of strange artifacts on the surface of the print which are they've sort of telegraphed through from some defects on the film of my 3D printer, but that's not too bad. I can put a new film in. I think that's almost ready to go to production, and Ben needs 6 of these. But I've since found out that this is more or less exactly the same as a London, Chatham and Dover meat wagon, in that it would have had 2 doors that went full height here instead of this drop down flap, and louvered panels in the sides here. So I think the same basic thing could produce 2 different body styles. And there's 2 types of underframe as well, depending on whether it was goods or passenger. So I think I might do those as well, and then we could have 4 variants of this little wagon. Anyway, it's been a fun little thing to put together. I'm looking forward to getting this little prototype. I'll throw a bit of paint over it and we'll see how it looks. But I think, or I hope, Ben will be quite happy with that. Now, before we put the matter of these cattle wagons to bed, I just thought I'll just quickly add that I've been working on some others as well. Now, I need for my model of Bexhill West a number of 16-ton mineral wagons. Now, I haven't done as much development work on these as I have with the cattle wagons, but they're already shaping up to be not too bad. So these will be the subject of a future video, and I've been experimenting with different settings to try and get the various bits of detail just how I want them to be, but they're working out okay, so expect to see some more of these in a future video. Now then, it's occurred to me as I'm editing this up that these things might be, others might like to have a go at these, so I'm going to make this the basis of a subscriber giveaway, I think. So at some point in the new year, when I've refined the file and just got some of the detail absolutely perfect, I've got to add the little corner cappings for example, I shall offer these 3D prints, or offer the files, shall I say, to anyone who's got a 3D printer. You can have those free of charge and make some yourself. Anyway, that's something else I've been working on. Now, the next item on today's agenda sees the return to the Turntable project. Now, this is something which hasn't been forgotten, and I've been working on it quietly in the background. Now, the main hold-up has been the fact that I've had all of the artwork prepared for an etched brass bridge, but that has I've just been holding on actually etching that because I've been making some alterations to my studio arrangements. Once the studio is up and running and the equipment's all sort of more permanently set up, production will start on that. But I now have potentially 5 of these things to make, and so with that in mind I thought I'd do a bit of a production engineering job on the mechanism and the well for the turntable. So I thought if I could spend a bit of time to simplify those things, make them as sort of robust and as reliable as possible, then when the etched brass pieces turn up I can sort of get straight on to constructing something onto a mechanical basis that hopefully is quite reliable. So this is the basic drive mechanism of the turntable. I've got the stepper motor there, a gear wheel. Now this one I couldn't find one with the right number of teeth on, so I've laser cut this, although I think a 3D printed one might be better. And currently this whole arrangement is just on a crudely cut disc, just to kind of prove it out. Now I've got the electronics hooked up, and I don't know if you could see that when I move the little joystick here, the turntable, this pulley is moving. That might be more obvious if I put something on it. So that's all working fine, and I can control the direction with the joystick, and to an extent I can control the speed. I've got this running really slowly at the moment, but I can speed it up, no problem at all. However, I'm having some difficulty with the programming. It's proving to be beyond me, so if there's anybody watching this who is an absolute whiz at programming an Arduino or C++, then I'd love to hear from you. I'm going to use a Hall effect sensor which will be mounted on the perimeter of the turntable well, and a little magnet in the end of the bridge so that it can automatically sort of home itself, and then from there I'd like to be able to program it to go to certain sort of tracks in certain angular positions, but that's beyond me. But currently we've got this aspect of the project working a treat. So with this being the base of the mechanism, there will be some little standoffs on here, and I've designed this thing. Now this is quite a poorly finished 3D print. I just printed this one on the fastest possible setting because I wanted it to print quickly rather than the 3 days it was telling me it was going to take if I did it on the fine setting. Now hopefully you can see that this tapers down into the middle. There's a little upstand, and this square in the middle is where the concrete pad that the centre bearing would sit. So that will bolt to the top of this mechanism on the standoffs, and little bolt head holes provided for that. I can fill those afterwards before the ring rail goes on. And hopefully you could see that that centre bearing actually sits proud of the this piece. There's a circular cutout for that to drop into, and there will be a variation on this component. This one has got a square cutout, but I'm going to redo this with a circular cutout to correspond with that, and it'll have some little brass nut inserts, so that will drop over, and 4 screws up from underneath will hold that centre bearing on, hold that in place nicely, and the bearing also. So that's, and then the bridge of course will be assembled onto here. Now I think that's all going to work pretty well. I'm certainly happy that the mechanical side of it is sorted out. It's just that little bit of the software with the electronics that I need to figure out. The drive for the turntable will be via this central pin, which is going to have this Tommy bar arrangement, and that will transmit motion to the bridge of the turntable via a slot, which is going to be formed into the base of it. So that's the basic idea. Apologies for the outer scale brick texture, that's what the software gave me without too much fiddling about. Now what I will show is I have borrowed some of Martin Wynn's excellent 3D chair models for the ring rail. Now the ring rail doesn't sit in normal chairs like those anyway, it sits on pads and with spikes, but I've included those just for now, just to help me sort of work out the relationship between that rail and the race rollers that run around here. So that's the idea. The bridge will turn and there will be a little magnet in the end just here, and the electronics will be able to register the home position via this Hall effect sensor, which is just down here. And then from that the software can be programmed to turn the bridge to any position that's required. Well, I think time-wise that'll have to be it for today. I think I've already said far too much. It's a shame really, because I've got a number of architectural projects, some of which are behind me here, that I think would make for interesting videos in themselves. In fact, I think it's probably about a dozen or so different things I've been working on. But we've run out of time for those today, so they'll have to come in a future video. Now I said in my last video that the updates would be far more frequent, and there's been a massive break between my last upload and this one, and the reason for it is because, and as I mentioned this briefly in the video earlier, I'll be putting together a studio space, a dedicated space in which to put all my equipment and I can build models in, and one of the ideas of that is I want to be able to take on commissions a little bit more easily. So I'm hoping that's coming to a conclusion really, the works there, and in probably a few weeks time I'll be able to share with you what that space is, and it's going to be ideal for filming the laser cutter amongst other things, so there'll be plenty of content to come in that direction. Anyway, until it's done I suspect I'm going to be a little bit slow with getting the next video up. Who knows, but until I do, I'd like to thank you all very much indeed for watching, and I hope to see you soon. Cheerio.